Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 2, and today we're looking at Section 2.6 on percent and mixture problem solving. In this section, we will solve percent equations, solve discount and markup problems, solve percent increase and percent decrease problems, and finally, we'll solve some mixture problems. And this is still part of SLOD, which is solve application problems using linear methods. All right, so we'll start with percent equations. My advice whenever you're solving a percent equation, and I'll show you some examples, is wherever you see the word is, change that to an equal sign. Wherever you see the word what or what number, change that to X. Wherever you see the word percent or a percent symbol, change that to either 1/100th or the decimal 0.01. And finally, change the word of to multiplication. So these are the three examples we're going to be looking at, and I will switch over to my tablet. All right, so the first example is what number is 88% of 1,000? So to show you what I was just talking about, I'm going to change what number to X. I'm going to change is to equals. 88 is 88. I'm going to change the percent sign to 0.01. I'm going to change of to multiplication. And then finally, 1,000 is 1,000. So you see that gives us a very nice equation, and there's really not a whole lot to do to solve it, right? It tells you X equals 88 times 0.01 times 1,000. That's just an arithmetic problem. So if you crunch the numbers, and feel free to use a calculator, you are going to end up with X equals 880. All right, pretty easy, right? Next example, and please, at any time, I encourage you to pause the video and try the problem yourself before I do it, and then come back and compare notes. All right, so the number 87.2 is just 87.2. I think they started the sentence with the words the number because there's some English rule that says you're not supposed to start a sentence with a number unless you write it out, which they didn't want to do. All right, just my guess. Is what becomes X? Percent becomes 0.01. Of becomes times. And 436 is 436. So this is an actual algebra problem. We do have to solve that for X. So the first thing I'll do is multiply 436 times 0.01, which comes out to 4.36. And then using the multiplication property of equality, we'll divide both sides by 4.36. And again, use your calculator to figure out what is 87.2 divided by 4.36. I believe it comes out to 20. Yeah, I'm sure that's right. All right, so the answer to the question, the number 87.2 is what percent of 436? The answer is 20%. All right, last example, and I definitely encourage you to try this one first. So please pause the video, try this one, come back and compare notes. All right, the number 126 is just 126. Is becomes equals. 35 is 35. Percent sign becomes 0.01. And by the way, that part of it is a little trick that I made up. I've never seen I don't think anybody else do that. What I like about changing the percent sign to 0.01 is that then at the end of the problem, if you're solving for an unknown percent, like in the last example, you don't have to remember to move the decimal point either 2 places to the right or 2 places to the left. Some people have trouble remembering which way it's supposed to go. So this way you don't have to worry about that. All right, and then what number becomes X? All right, so it ends up looking like a kind of similar equation to the last one. 35 times 0.01 is 0.35. So now I'll divide both sides by 0.35. And I think I will use my calculator for this one. 126 divided by 0.35 comes out to 360. So the number 126 is 35% of 360. All right, back to the presentation. All right, here's another example of solving a percent equation. This time they've built sort of an interesting story around it. Columbus is a town in Indiana whose adult population is approximately 29,250. How many of these adults, based on this circle graph, which we're going to look at in just a second, how many of these adults might you expect to talk 61 to 120 minutes on the phone each day? This is kind of an old graph. Notice it says on their home phone. If they were to repeat this survey now, I would expect the results to look a little different. All right. Okay, so again, so looking at the circle graph, if you find the section for 61 to 120 minutes, it says that accounts for 8% of the population. So this question really turns into, what is 8% of 29,250? So let me bring up the tablet again, where I have that question written out. So what number is 8% of 29,250? All right, so again, this is really just an arithmetic problem. 0.08 times 29,250. Okay, comes out to exactly 2,340. And I'll add the word adults. All right, moving right along. Back to the presentation. Okay, so next we're going to talk about discount and markup problems. So I don't know if I really think of these as formulas. This is just how you do the problems. So to do a discount problem, you have to find two things, or sometimes they just ask you for one of these things. To find a discount, you find the percentage of the original price. And then the new price is the original price minus the discount. And similarly, for a markup problem, it works almost exactly the same way, except notice that with a discount problem, you subtract the discount. With a markup problem, of course, you add the markup. So to find the markup, you find the percentage of the original price and then add that to the original price to find the new price. Okay, so there are three examples here, I think. So I'm just going to switch over to the tablet and we can look at them on there. Some of these examples are a little dated, like this one. A music store remember when they used to have those, is advertising a 25% off sale on all new releases. Find the discount and the sale price of a newly released CD, remember when they used to have those, that regularly sells for $12.50. Okay, so first we're going to find the discount. Notice this problem is asking for both. So the discount is 25% of $12.50. Oops. Okay, so I'm going to say 25 times 0.01 times 12.50. Okay, that comes out to exactly 3.125. Generally, when you're dealing with amounts of money, you should round to the nearest penny. So they can't take off $3.12.5, right? So usually what they'll do is they'll just round up the discount. So the discount would be $3.13. And then the new price would be the original price, which is $12.50 minus $3.13, which comes out to $9.37. All right, next example. All right, a retirement dinner for two is $65.40, including tax. Find the total cost if a 20% tip is added to the given cost. So problems about tipping are technically markup problems because you're marking up the amount of the check in order to include the tip. Okay, so the tip, again, which is a markup, is 20% of $65.40. 20 times 0.01 times 65.40. That comes out to $13.08. So this time they're only asking for the total cost. So I'm not going to give the tip separately as an answer. It's just going to be the total cost, which is the original check, $65.40 plus $13.08 comes out to $78.48. All right, last example. This is one I made up. Okay, and I made this up so long ago that I can't remember if everything here is absolutely factual. So take this with a grain of salt. For example, I don't remember if it's true that the Merced College bookstore actually marks textbooks up 25%. I might have made that up. All right. But so let's say, suppose the Merced College bookstore marks textbooks up 25% before selling them. Suppose that's true. If a 12-month homework access code sells for $109.20, what did the bookstore pay for the access code? Now, this problem is trickier than it might look. All right. Think for just half a minute about what's different about this problem than, say, the last problem, right? This is another markup problem. Okay, but how is it different from that tipping problem? Well, the biggest difference is instead of giving me the original cost, they're giving me the total cost after the markup is added. Okay. So what a lot of students are going to be tempted to do in this situation is to find 25% of 109.20 and then subtract that in order to find the original cost. Unfortunately, it turns out that is not the correct way to do it. In some problems, that might get you kind of close to the answer, but it's not going to get you the correct answer, okay? So for this one, I am going to use a variable. I'm going to say let X equal the original cost, okay? And then I'm going to go ahead and treat this as a markup problem. It is a markup problem. So the amount of the markup would be 25% of X, right? Which I'm going to write as 25 times 0.01 times X. So I'm going to write that as 0.25X. And then the total cost, which in this problem is given to be 109.20, is equal to the original cost, which we're calling X, plus the dollar amount of the markup, which is 0.25X. Okay. All right, so this problem is a little trickier than, the couple that we did before this, but it's one that everybody should know how to do. It's one of my favorite kinds of problems. All right, so now that we've set up this equation, we should be able to solve for X. Let me go on to a new screen here. So the equation we had written down was 109.20 equals X plus 0.25X. So for one thing, be careful how you combine those like terms. Remember to think of X as 1X. And now think about what is 1X plus 0.25X. It is 1.25X, right? Okay, so to solve for X, I'm going to divide both sides by 109.20, by 1.25. And while I was talking there, I went ahead and crunched those numbers. It turns out that X is equal to $87.36. I haven't been talking a lot about Mitchell's commandments in this section so far. So remember, it's a good idea. Well, we did them in this problem, right? So X is the original cost. I've defined my variable. And now I'll write my complete sentence. $87.36 is the original cost. All right. All right, next we'll look at percent increase and decrease. Percent increase or decrease is given by this formula. Just take the new amount minus the old amount and divide by the old amount. All right, so our first example is going to be iceberg lettuce is grown and shipped to stores for about 40 cents a head, and consumers purchase it for about 86 cents a head. Find the percent increase. And there's another example, which I will just show you on the tablet. All right, here we go. So new amount minus old amount divided by old amount. The new amount is 86 cents. The old amount is 40 cents, and we're dividing by 40. So that comes out to 46 divided by 40. I think that's, oh no, it's not. Let's see. Bring up the calculator. 46 divided by 40 is 1.15. Now, what you have to understand about this number is that this is not written as a percent. So in order to change a number that's not a percent into a percent, you have to multiply it by a form of 1, which if we're trying to convert it into a percent would be 100%. Okay, so the percent increase written as a percentage would be 115%. All right, and the second example. During the 1982-83 term, the Supreme Court made 151 decisions, while during the 2007-8 term, they made only 72. And they want us to find the percent decrease in the number of decisions rounded to the nearest 1/10 of a percent. So again, we're going to use the formula new amount minus old amount divided by old amount. The new amount is 72. The old amount was 151, and we're finding that as a percentage of 151. Now, 72 minus 151 is negative 79. The negative just reflects the fact that it is a decrease. So as soon as we incorporate the word decrease in here, we will drop the negative sign. 79 divided by 151 is about negative 0.523. Okay, so I think I will actually replace that with our wiggly equal sign. Again, we have to change that to a percentage. That is not currently written as a percentage. Okay, so that would be a 52.3% decrease. Notice I'm taking out the negative sign and just putting in the word decrease.